Example 1, sketch the following functions using transformations of the 5 key points in the graph of y equals sine of x. So looking at part A, we have y is equal to -3 sine of x minus 20 plus 4. First thing we need to do is identify the values of a, d, and c. So if we compare it to this very general form, we can see that a right here is the number that's following the equal sign, and it's -3. That d is the number that's being taken away from x, and in this case it's 20. And that c is the last number that's added at the end, and in this case it's 4. Next, we have to come up with the points on the graph of y equals sine of x. So we're going to determine these points using a table of values. The x-coordinates will be in degrees, and they will start at 0 going up by 90. So 0, 90, 180, 270, and then 360. To determine the corresponding y-coordinates, you would take these x values and plug them into the equation. Make sure your calculator is in degree mode. So sine of 0 would give you 0. Sine of 90 would return a value of 1. Sine of 180 is 0. Sine of 270, -1. Sine of 360, 0. And we will call these the old coordinates. And now we're going to apply our transformation formulas to determine the new coordinates that are on the graph of the given equation or function. And we will call them the new coordinates, x new and y new. So to get the new x coordinates from the old ones, we're simply going to have to just add the value of d. D is 20, so we're going to take 0, 90, 180, 270, and 360, and add 20 to all those values to get 20, 110, 200, 290, and 380. To get the new y coordinates from the old ones, we're going to multiply by a and add c. So in our case, we're taking the values of 0, 1, 0, -1, 0. We're going to multiply them all by -3 and add 4. So when we start with 0 and we multiply by -3 and add 4, we get 4. That would also give us that same answer in the middle here, since we're starting with 0 there as well, and at the very end. If we take 1 multiplied by -3 and add 4, we get 1. And if we take -1 multiplied by -3 and add 4, we get 7. Now it's just a matter of plotting these points on a graph. So I will scale the x-axis by 50s, and then the y-axis by 1s. And now we're ready to plot the points. So 20 and 4 be somewhere down here. 110 and 1. 290 and 7. I missed 204 here. And then 380 and 4. And once these 5 points are plotted, a smooth curve can be drawn through those points. And this would be the graph of the given function y is equal to -3 sine of x minus 20 plus 4. Okay, let's look at one more example here. We have the equation y equals 4 sine of x plus 60 minus 7. Again, first we're going to identify the values of a, d, and c. A is 4 in this case. D is negative 60, because the number that we're subtracting here is actually negative 60 for us to see an addition sign inside the brackets, and then C is negative 7. Then we're going to start with the same points on the graph of y equals sine of x, and again we can come up with them using a table of values. And they will be called the old coordinates. So for the x coordinates, we have 0, 90, 180, 270, and 360. For the y coordinates, if I sub these x coordinates in the equation y equals sine of x, I'll get 0, 1, 0, negative 1, and 0. Now we're going to determine the new coordinates. And we're going to do this by applying our transformation formulas. So to get the old coordinates from the new ones, we're going to add negative 60. So adding negative 60 to all these values gives me negative 60, then 30, 120, 210, and 300. To get the new y coordinates from the old ones, we're going to multiply by our a value of 4 and add our c value of negative 7. That gives us negative 7 for the top, middle, and bottom. Give us negative 3 for the second number, and it would give us negative 11 for the fourth number. Now we just need to plot the points here. Again, I'm going to scale my x-axis by 50s and my y-axis by 1s. Okay, so negative 60 and negative 7 would be somewhere down here. Oops. And then 30 and negative 3, 120 and negative 7, and 210 and negative 11. And then 300 and negative 7. Drawing a smooth curve through those points, I would end up with a sine function, and the sine function would represent the given one of y is equal to 4 sine x plus 60 minus 7. Okay, verify that it seems like as if the graph is in the right location by looking at your translations. From the equation, we know that the entire graph had to be translated 60 units to the left and 7 units down. So it looks like it's been moved to the left and down. So this graph makes sense. We also know that it should start going up from left to right since my a value is positive.